Alright, so for number 2, you have to find the inverse and then use composition to prove that your inverse is correct. So first thing is we switch off the g of x and replace it with a y. And then we, oops, it's a 3 cube. Let me just redo it. It's 4x cubed minus 2. So now we're going to add a 2. Your goal is to leave x by itself. So you have y plus 2 equals 4x cubed. We're going to divide by 4. And so now you have y plus 2 over 4 equals x cubed. So now you're going to take the cube root of both sides. And so that leaves x by itself. So cube root of y plus 2 over 4 equals x. We switch x and y. So I'll just put the y on the left side. And then switch the notation to g inverse. Okay, so this is our inverse. And so now we have to check our answer. So let me just put a little dividing line here. So we're going to do g, oops, I keep writing f. G of g inverse of x. Okay, we're going to do that one first. So that means we're going to take 4, and then in place of the x, we're going to write cube root of x plus 2 over 4 cubed minus 2. So cubing the cube root gets rid of the radical, so you have 4 times x plus 2 over 4 minus 2. So then the 4's cancel. And so now you have x plus 2 minus 2, and 2 minus 2 is 0, so that leaves you with x. And so we do the other direction, g inverse of g of x. And so we start off with cube root, and then this in parentheses is the x, so I'm going to put in 4x cubed minus 2 plus 2 all over 4. Okay, so now the 2 minus 2 is 0. And so that leaves you with 4x cubed over 4, like that. And the 4 over 4 cancels. So you're left with cube root of x cubed, which is x. And because both of them gave you x, both compositions gave you x, that means that my inverse is right. Alright, so for number 4, it's a square root function. Same thing, find the inverse and then prove that your answer is right by using composition. Before we start though, because it's a square root, I know that the domain for this one is that x has to be greater than or equal to negative 3. And why is that? Because negative 3 here makes this radical 0. And I cannot use any numbers smaller than negative 3. Because if I use numbers smaller than negative 3 here, this number is going to be negative, which is not would give me a not real number, an undefined number. So we just have to put in this domain right here, okay? And then I'll show you how we're going to use it later. But for now, just kind of put it here on the side. This is the domain. And why? Because I cannot have negative numbers inside of here. Okay, only 0 or bigger. So now, switch, oops, y equals square root of x plus 3 minus 2. So I'm going to add 2 to both sides. So that's going to leave y plus 2 equals square root of x plus 3. I'm going to square both sides because I want to get rid of the radical. So square and square. And so now you have y plus 2 squared equals x plus 3. We're going to subtract the 3. And now x is by itself. Okay? So now you switch the x and the y. And then change the notation. Okay, now remember, since this is supposed to be a one-to-one function, the domain of this one has to be x greater than or equal to -2. And why is that? Because -2 would make this 0, and that's where the vertex is, because h is -2. So this is how you would define the domain, okay, and restrict the domain so that you have a one-to-one function. And with that in mind, because I have the domains for both my inverse and my original function, I know that the range is the same as the domain of the inverse. So the range is going to be y greater than or equal to -2. And over here the range is going to be the same as the domain of the original, except for y. You're going to say y is greater than or equal to -3. Okay, so this is going to come in handy later when we're going to confirm it if we ever have to graph these functions. It comes in handy then. Okay, so now let's continue and prove that our inverse is right. So we're going to use composition. So we have h of h inverse of x equals, so I'm going to take square root of x plus 2 squared minus 3, okay, plus 3 minus 2. So this here, all of this is x, okay. So what I did is I replaced this x with this whole inverse function, okay. So this x right here is this one right here. So now what happens? The 3's are gone. 3 minus 3 is 0. And so you have square root of x plus 2 squared minus 2. While squaring a square root is eliminating the radical, right? So the radical's gone. So now I have x plus 2 minus 2. The 2's are gone, so I have x. Okay? Now we do the other direction. H inverse of h of x. Okay, so we start off with the inverse. I'm going to put a bracket. So instead of x, I'm going to put in radical x plus 3 minus 2. So there's my x. Plus 2 squared minus 3. Okay, so notice again, where does it start with h inverse? This x right here got replaced by this whole function over here. So right here, this is where the x used to be on the inverse function, but it's now replaced by the h of x function. So what happens here? 2 minus 2 is gone, and then so you have x plus 3 squared minus 3. So now the radical's gone, so it's x plus 3 minus 3. The 3's cancel, and you're left with x. So we were able to show that both compositions equal x, so that means that our answer is correct. Alright, for number 6, we have to restrict the domain. So you ask yourself, what makes this 0? And the answer is 9. So as you can see, h is 9. So that's where the vertex is, right? 9, 4. So I'm going to look at all values greater than or equal to 9. So my domain would be x greater than or equal to 9. Okay? So now I go ahead and do the look for the inverse. So this becomes y equals so I'm going to subtract a 4. So y minus 4 equals 3 times the quantity of x minus 9 squared. Do not distribute the 3. Okay, we're peeling away at the x step by step, so the next thing we do is divide by 3. Okay, and so now x minus 9 squared is by itself, right, on the right side. So what we're going to do next is take the square root of both sides. Oh, I don't need a 2 there, sorry. Let's take a square root. And so what happens is I have y minus 4 square root of that equals x minus 9. The radical is, the inverse of squaring is taking the square root. So now you have x minus 9. So now we add 9, and now x is by itself. Now 9 cannot be added to the -4 or inside the radical. It has to stay outside. So we switch the x and the y. I usually put it at the end. on the left side. And then plus 9 has to be outside. And then change the notation, so G inverse of x equals this. So this is what we think the inverse is right here. We got to confirm it now. Oh, and by the way, right here, you ask yourself what makes the numerator here 0, what makes this 0, and the answer is 4. So this tells you that the domain of the inverse function is x greater than or equal to 4. So then the range, remember how the domain and range switch for the original and the inverse? So for the range of the g of x function would be y greater than or equal to 4, and the range of the inverse would be y greater than or equal to 9. And if you could see the connection here, see how this and this is here, and this 9 and this 9, same number, okay? Now let's go ahead and do the inverse, or the composition rather. So we're going to do g of g inverse of x. So we take 3, I'm going to use brackets so I could keep the x together. So this is going to be square root, square root of x minus 4 over 3 plus 9. This is my x minus 9 squared plus 4. So the 9 minus 9 is 0. Okay? And so now I'm going to square the square root, so I get 3 times, since I'm going to square, here's the square root, and I'm going to square it because these are gone. So these are no longer in the picture. So it's the square root squared. So that's going to give you just the x minus 4 over 3 plus 4. And so 3 over 3 gone. And so x minus 4 plus 4, that's x. Okay? So now we're going to do the other direction, g inverse of g of x. So I start off with a radical. And in the parentheses, in place of the x, I'm going to put 3 x minus 9 squared plus 4, the whole function, okay? The whole g of x function, minus 4 over 3 plus 9. Okay? So right here I've got 4 minus 4 is 0. And so now I have square root of 3 x minus 9 squared over 3 plus 9. And so 3 over 3 is 1, so that's gone. And so now I have a square root squared, right? So that simplifies to x minus 9, and then I have a plus 9 outside, so the 9's are gone. So that leaves me with x. So this proves that I got x for both directions, for both compositions, so that means that my answer right here is correct.